Function and variable ordering. Each individual Viper smart contract consists of a single Viper file only. In other words, all of a given Viper smart contract's code, including all functions, variables, and so forth, exists in one place. Viper requires that each smart contract's function and variable declarations are physically written in a particular order. Solidity does not have this requirement at all. Let's take a quick look at a Solidity example. In this example, the function called top function is calling another function, lower function. Top function is also assigning a value to a variable called initialized below top function. As you can see, Solidity does not require these functions and variables to be physically declared before being called upon by the executing code. This is valid Solidity code that will compile successfully. Viper's ordering requirements are not a new thing. In fact, these ordering requirements have always been present in Python programming. The ordering required by Viper is straightforward and logical, as illustrated in the next example. The bool, public with one argument, bool. At public, define top function with no parameter. Arrow bool, self.theBool equals true. Return self.theBool. At public, define lower function with no parameters. Assert self.topFunction, called with no arguments. This shows the correct ordering of functions and variables in a Viper smart contract. Note how the variable the bool and the function topFunction are declared before they are assigned a value and called respectively. If the bool was declared below topFunction, or if topFunction was declared below lower function, this contract would not compile. Compilation. Viper has its own online code editor and compiler, which allows you to write and then compile your smart contracts into bytecode, ABI, and LLL using only your web browser. The Viper Online Compiler has a variety of pre-written smart contracts for your convenience, including contracts for a simple open auction, safe remote purchases, ERC20 tokens, and more. This tool offers only one version of the compilation software. It is updated regularly, but does not always guarantee the latest version. Etherscan has an online Viper compiler which allows you to select the compiler version. Also, Remix, originally designed for Solidity smart contracts, now has a Viper plugin available in the Settings tab. Notes: Viper implements ERC20 as a pre-compiled contract, allowing these smart contracts to be easily used out of the box. Contracts in Viper must be declared as global variables. An example for declaring the ERC20 variable is as follows: token, address with one argument, ERC20. You can also compile a contract using the command line. Each Viper contract is saved in a single file with the .vy extension. Once installed, you can compile a contract with Viper by running the following command: viper _hello_world.vy. The human-readable API description in JSON format can then be obtained by running the following command: viper-f json ~hello_world.v.py. Protecting against overflow errors at the compiler level. Overflow errors in software can be catastrophic when dealing with real value. For example, one transaction from mid-April 2018 shows the malicious transfer of over 57 times 10 to the 57th power of BEC token. This transaction was the result of an integer overflow issue in Beauty Chain's ERC20 token contract, bectoken.sol. Solidity developers do have access to libraries like SafeMath, as well as Ethereum smart contract security analysis tools like Mithril OSS. However, developers are not forced to use the safety tools. Put simply, if safety is not enforced by the language, developers can write unsafe code that will successfully compile and later on successfully execute. Viper has built-in overflow protection, implemented in a two-pronged approach. Firstly, Viper provides a SafeMath equivalent that includes the necessary exception cases for integer arithmetic. Secondly, Viper uses clamps whenever a literal constant is loaded, a value is passed to a function, or a variable is assigned. Clamps are implemented via custom functions in the low-level Lisp-like language compiler and cannot be disabled. The Viper compiler outputs LLL rather than EVM bytecode. This simplifies the development of Viper itself. Note: LLL is the abbreviation for the low-level Lisp-like language. Reading and writing data. While it is costly to store, read, and modify data, these storage operations are a necessary component of most smart contracts. Smart contracts can write data to two places. 1. Global state. The state variables in a given smart contract are stored in Ethereum's global state tree. A smart contract can only store, read, and modify data in relation to that particular contract's address. In other words, smart contracts cannot read or write to other smart contracts. 2. Logs. A smart contract can also write to Ethereum's chain data through log events. While Viper initially employed a _log__ syntax for declaring these events, an update has been made that brings its events declaration more in line with Solidity's original syntax. For example, Viper's declaration of an event called mylog was originally mylog: _log__ called with the argument. The syntax has now become mylog: events called with the argument. It is important to note that the execution of the log event in Viper was and still is as follows: log.mylog of 123. While smart contracts can write to Ethereum's chain data through log events, they are unable to read the on-chain log events they have created. Notwithstanding, one of the advantages of writing to Ethereum's chain data via log events is that logs can be discovered and read on the public chain by light clients. For example, the log's bloom value in a mined block can indicate whether or not a log event is present. Once the existence of log events has been established, the log data can be obtained from a given transaction receipt. Conclusions. Viper is a powerful and interesting new contract-oriented programming language. Its design is biased toward correctness, at the expense of some flexibility. This may allow programmers to write better smart contracts and avoid certain pitfalls that cause serious vulnerabilities to arise. Next, we will look at smart contract security in more detail. Some of the nuances of Viper design may become more apparent once you read about all the possible security problems that can arise in smart contracts.